The article numbers 305, 318, 333, 363, and 373 are found in the 2008 National Electrical Code. The National Electrical Code, or NEC, is a comprehensive set of standards that govern the safe installation of electrical wiring and equipment. It is updated every 3 years by the National Fire Protection Association, or NFPA. Each edition incorporates revisions, additions, and deletions to reflect the latest advancements in electrical technology and safety practices. Because the NEC undergoes regular updates, it's crucial to know which edition is currently enforced by the relevant authorities in your jurisdiction. Different states, counties, and municipalities may adopt different editions of the NEC, and it is not uncommon to see a lag between the publication of a new edition and its adoption by local jurisdictions. Examining agencies for licensing purposes adopt particular editions to test against. Therefore, the most important step is to confirm with the licensing agency which specific edition of the NEC is the basis for the examination. The licensing agency will provide information on which edition of the code is being tested to ensure study efforts are properly focused. Using the incorrect edition can lead to confusion and potentially incorrect answers in the exam, as code requirements and article numbers can change from one edition to the next. Article 305 covers temporary electrical power and lighting installations. These installations are commonly used during construction, remodeling, maintenance, repair, or demolition of buildings, structures, equipment, or similar activities. This article outlines the requirements for the safe installation and use of temporary wiring, including grounding, overcurrent protection, and the types of wiring methods permitted. Temporary installations must comply with the general requirements of the NEC, as well as the specific provisions outlined in Article 305. This helps ensure the safety of workers and the public during the period when temporary electrical systems are in use. Article 318 addresses cable trays, which are structural units used to support cables and raceways. Cable trays are commonly used in industrial and commercial settings to manage and protect large numbers of cables for power, control, instrumentation, and communication systems. This article specifies the types of cable trays permitted, the methods for installing cables in cable trays, and the requirements for grounding and bonding cable trays. Cable trays must be installed in accordance with the manufacturer's instructions and the requirements of the NEC to ensure the safe and reliable support of cables. Article 333 pertains to armored cable, also known as AC cable. Armored cable is a factory assembly of insulated conductors enclosed in a flexible metallic sheath. It is commonly used for branch circuits and feeders in both exposed and concealed locations. Article 333 specifies the types of armored cable permitted, the allowable uses and restrictions, and the requirements for installation, support, and termination. Armored cable must be installed in accordance with the NEC to ensure the integrity of the cable and to provide proper grounding and bonding. Article 363 covers flat cable assemblies, or Type FC cable. This type of cable consists of parallel conductors embedded in an insulating material, forming a flat cable assembly. Type FC cable is typically used for undercarpet wiring and for supplying power to lighting fixtures and appliances. Article 363 specifies the allowable uses and restrictions, the installation requirements, and the methods for connecting and terminating Type FC cable. The use of Type FC cable is subject to specific limitations outlined in the NEC, such as the maximum voltage and current ratings, and the types of occupancies where it is permitted. Article 373 addresses cabinets, cut-out boxes, and meter socket enclosures. These enclosures are used to house electrical components such as circuit breakers, fuses, switches, and meters. Article 373 specifies the construction requirements, the installation requirements, and the grounding and bonding requirements for these enclosures. Cabinets, cut-out boxes, and meter socket enclosures must be installed in accordance with the NEC to provide a safe and secure enclosure for electrical components and to protect against electrical shock and fire hazard. Each of these articles within the NEC provides detailed requirements for specific wiring methods, equipment, and installations. These requirements are intended to ensure the safety of people and property by minimizing the risks of electrical shock, fire, and other hazards. It is essential for electrical professionals to have a thorough understanding of these articles and to comply with the NEC when designing, installing, and maintaining electrical systems. The NEC is a living document that is constantly evolving to reflect the latest advancements in electrical technology and safety practices. Regular review and updates are necessary to stay current with the code and to ensure compliance with the latest requirements. Furthermore, it is important to understand how the NEC interacts with other applicable codes and standards. Electrical installations are often subject to other regulations, such as built-in codes, fire codes, and accessibility standards. Coordination between these different codes is essential to ensure that the overall installation is safe, compliant, and meets the needs of the building occupant. Firstly, understanding the scope of each article within the NEC is essential for proper application. The scope defines the specific types of installations, equipment, or wiring methods that are covered by the article. Secondly, familiarity with the definitions provided in Article 100 of the NEC is crucial for interpreting the code correctly. Article 100 provides definitions for many of the terms used throughout the code, and these definitions are essential for understanding the intent and meaning of the code requirements. Thirdly, grounding and bonding are fundamental concepts in electrical safety, and the NEC contains extensive requirements for grounding and bonding electrical systems. Proper grounding and bonding helps to minimize the risk of electrical shock and to provide a low impedance path for fault currents to flow back to the source, which is essential for the proper operation of overcurrent protection devices. Fourthly, overcurrent protection is another critical aspect of electrical safety, and the NEC specifies the requirements for overcurrent protection devices such as circuit breakers and fuses. Overcurrent protection devices are designed to protect electrical circuits and equipment from overloads and short circuits, which can cause overheating, fire, and equipment damage. Fifthly, wiring methods are the various ways in which electrical conductors are installed and protected. The NEC recognizes a variety of wiring methods, each with its own set of requirements for installation, support, and protection. Common wiring methods include conduit, cable trays, armored cable, and non-metallic sheath cable. Sixthly, equipment listing and labeling are important aspects of electrical safety. The NEC requires that electrical equipment be listed and labeled by a recognized testing laboratory, such as Underwriters Laboratories, or UL. Listing and labeling indicate that the equipment has been tested and found to comply with applicable safety standards. Seventhly, installation requirements are the specific rules and guidelines for installing electrical equipment and wiring. The NEC provides detailed installation requirements for various types of equipment and wiring methods, including requirements for spacing, support, protection, and termination. Eighthly, it is essential to understand the requirements for special occupancies and equipment. The NEC contains specific requirements for electrical installations in hazardous locations, healthcare facilities, and other special occupancies. These requirements are designed to address the unique hazards and risks associated with these environments. Ninthly, the NEC includes requirements for emergency systems, which are designed to provide power and lighting during a power outage. Emergency systems are essential for maintaining safety and critical operations in buildings and facilities where a power failure could pose a significant risk. Tenthly, the NEC contains requirements for communication systems such as telephone, data, and cable television wiring. These requirements are designed to ensure the safety and proper operation of communication systems and to prevent interference with other electrical systems. Staying up to date with the latest edition of the NEC and understanding its requirements is essential for electrical professionals to ensure the safety and reliability of electrical installations. Continuing education and training are important for maintaining competency and keeping abreast of changes in the code. Always check with the local authority having jurisdiction for specific requirements and interpretations of the NEC.